All right, so this video is going to be a little bit about acids and bases, and specifically how we do some of the calculations, um, both pH as well as some other related calculations. So we'll take a look at this example that we have here, and then we'll kind of touch on a few things along the way as we solve this problem. So it says that a solution has OH minus concentration. So remember, the OH minus is the hydroxide, and the square brackets that you see around it means concentration of. Usually that means in units of molarity or moles per liter. So we're told here that the solution has a concentration of hydroxide as 2.5 times 10 to the minus 6 molar, which means moles per liter. We need to find the pH of the solution. We need to say whether it's an acid or a base, and then we also need to determine the H plus concentration, which is the hydrogen ion concentration. And then just as a quick reminder, okay, the H plus is also written as the hydronium, which is a H3O plus ion. Okay, so you'll see both of these two, the H plus, the proton concentration or the hydrogen ion, and the hydronium, they're sometimes used interchangeably. Don't get confused, it means the same thing. All right, so first thing we need to figure out is what is the pH of the solution. So in order to do that, we need to use probably the most important equation in acid-base chemistry, which is the pH equation. So that is pH is equal to the negative log of the H plus ion concentration. Okay, so this then means that in order to use this equation, we need to find the H plus concentration, which is actually the last question listed here. So how are we going to determine that, right? So we need the H plus in order to determine pH. Well, we can use a couple ways that we can solve this. We can use the ion product for water, and in most cases, the systems that we're dealing with are aqueous solutions, so we can use the ion product for water, which says that if I take the H plus concentration for a solution, I times it by the hydroxide concentration, I always get the same number, and that's 1.0 times 10 to the negative 14. All right, so that's the relationship that we can use to help determine or calculate the H plus. So if I know what the OH minus is, I can plug it into this equation, do a little bit of algebra on it, and determine the H plus. All right, so if I rearrange that equation, I can now see that the H plus is equal to 1.0 times 10 to the negative 14. I'm going to divide that by the OH minus concentration. Okay, so I know what that OH minus concentration is. It's over here. Okay, so I'm going to substitute that in, 1.0 times 10 to the minus 14 divided by 2.5 times 10 to the, what is that, minus 6. Okay, and then that is going to give me the concentration of H plus. So we can evaluate that, which sounds simple enough, but you want to make sure that when you input this into your calculator, all right, in order for your calculator to do what you want it to do, you need to give it the proper instructions. What usually tends to be very helpful with this is if you make sure that you put parentheses around each of these numbers written in scientific notation, it will make your life a lot easier. So substitute or plugging those into your calculator then would give you the H plus concentration. So when I plug that into my equation, or into my calculator, I'm sorry, I get 4.0 times 10 to the negative 9 molar. So that is my H plus concentration. So to determine my pH, I'm going to use my pH equation up here, substitute that value in. So pH equals negative log of 4.0 times 10 to the minus 9 molar. So again here, what you want to do is make sure that you enter that correctly, or as you see it, into your calculator, because I'm going to take the negative value of the log. Okay, and in most cases, once you hit that log button, it opens the parentheses for you. So 4.0 and then times 10 to the negative 9. Make sure that you close your parentheses at the end. Okay, and that's going to give you a value of, in this case, it's 8.0. 40. You don't need to worry about sig figs with the logs. There are rules for sig figs, but we're not going to worry about them too much in our class. So the pH of the solution then ends up being 8.40. Okay, so that's the answer to the first question. We also determined, just by the way, the answer to the third question, the H plus concentration, which is this. And then we also determined the pH is what we needed to do originally. Now, obviously, we have a pH value. So remember, when your pH is less than 7, that means that that solution is acidic. If the pH is greater than 7, that means that it is basic. So because my pH is more than 7, that solution is going to be a base in this particular example. Okay, so now we're going to take a look at a slightly different way to approach the same problem. So in the previous section, we determined the pH to be 8.4. Based on that, we said that it was a base, and then in order to determine the pH, we calculated the hydrogen ion concentration as 4.0 times 10 to the negative 9. So another approach to this problem is as follows. So if we're given the hydroxide ion concentration, or if we know what that is, what we can do is we can calculate something called the P, not the pH, but the pOH. Okay, and what the pOH is going to be very similar to the pH, except we're going to take the negative log of, not the H plus, but the OH minus concentration. All right, so if you remember the pH, and I'll write this off to the side here, the pH was a negative log of H plus, right? We're taking the same idea. The little p there in the front really means negative log of something, all right? So if I take the negative log of this, my POH would be the negative log of the H plus, so that's 2.5 times 10 to the negative 6. So if I take that and I stick it in my calculator, okay, that's going to give me the value for the POH, so negative log of 2.5, and then times 10 to the negative 6, and then I close my parentheses, and that's going to give me a value of 5.60. Okay, and that is going to be my pOH for this solution. Now remember, I wanted to find the pH, right? So how this is helpful is as follows. When you have a solution and you take the pH of that solution and you add it to the pOH of that solution, you always end up with 14.0. This is just another way to express that ion product relationship we saw earlier. So what I just found here was the pOH. I need to find the pH. Simple math would tell us that the pH here would be 14.0 minus the pOH. Okay, so that's going to be 14.0 minus the 5.60, and then that's going to give me my value here of the exact same value, 8.4, as my pH. Okay, so as you can maybe see, it's a slightly quicker way to get to the same endpoint, but you kind of have to realize how that actually works. All right, so this is using that same ion product relationship, but now expressed as the negative log relationships. In this case, we're taking the pOH, which is a negative log of the OH minus. Once I have my pOH, if I add that to the pH, I always get 14. It makes it a little bit easier to work with the numbers after that because they're regular old numbers. Do a little subtraction, some mental gymnastics there, and I end up with the same answer as I did previously. Now, another thing here that you probably have seen when you've done a few of these is that you can look at several things during the course of a problem to help you determine that the answer itself makes sense. So for instance, we determined in the previous step what the H plus concentration was. It was 4.0 times 10 to the negative 9. So when you are given, or when you know, or you calculate the H plus concentration and it's written in scientific notation, typically the pH is going to be very, very close to what that exponent is. Okay, so my exponent here is 10 to the negative 9. my pH ended up being fairly close to 9, right? So that's how you can check to see whether your answer is in the right ballpark or not, is just by looking at some of these numbers and making some generalizations. Okay, so the last thing that we'll take a look at here is how we actually go in the other direction. So everything we've looked at so far is we're given the hydroxide concentration, so we're given the concentration of something, and we're able to use that to determine the pH, determine whether it's an acid or a base. We looked at a slightly different way of approaching the same problem to determine the pH of the solution. Now, in some cases, we're going to be measuring the pH, and then we need to determine the concentration of the hydrogen ion in this case. So in this case, we said if the pH of a solution is 9.7, what is the H plus concentration? All right. So now we're going in sort of the opposite direction. So we know that the pH, by definition, is the negative log of the H plus. So if I wanted to determine the H plus concentration, we need to work with logs and be able to know how to manipulate them. So the way that we rearrange that equation is that 10 raised to the power of the negative pH is equal to the H plus concentration, right? And if I know what the pH is, I simply stick it into that relationship, and that's going to give me my H plus concentration. So if I substitute my values, so 10 raised to the negative 9.7, you need to now evaluate that, right? You can't just leave that as your answer. So you stick it into your calculator and you hit enter. So that's going to give me 1.99 times 10 to the negative 10, and then that's going to be molar um, as your concentration. Okay, so we have our concentration here of the H plus that we calculated. And again, as we saw, as I mentioned previously, we can kind of work backwards and see whether or not our answer makes sense. If that's my H plus concentration, right, I look at my exponent, my pH should be a number really close to the 10, and it is. It's 9.7. Right, so that's how you can double check your answers along the way to make sure that they make sense, both in terms of units, but also in terms of the actual magnitude or the range of the numbers. Hopefully you found this a little helpful. We'll see you next time.